Hello, we will talk today about requirements management in Catia Magic with SysML. This is like crash course on this topic. We'll talk about this in context of cruise missile sample. So what we will touch? We will touch authoring, editing in SysML, traceability, validation verification through the simulation of SysML, change and configuration management with Teamwork Cloud and Suspect links, synchronization with external requirement management tools like DOORS, traceable requirements management as part of 3D Experience platform, JAMA, and we'll talk about documentation collaboration in Cameo Collaborator web-based app. And here we see Catia Magic, Cyber Systems Engineer, Cameo Systems Modeler. And here we have requirement which is satisfied by the solution architecture. We have a missile, propulsion system, airframe, and airframe diameter and height affects the range, how far the missile will fly. And with analytical model, help of analytical model, as we can see here, we can calculate that this requirement is satisfied or not. Editing, as you know, in SysML is possible through different views. Like for requirements, we have this editing in the table. You can just directly change requirement in the table, specify new distance, and other characteristics. You can create a hierarchy of requirements. The best way to do that hierarchy is directly in the package. Here you can just drag the requirements where it's needed, right? And then you can also show requirements in diagrams. So, and why is that in diagrams? Because it is a convenient way to satisfy those requirements with required part of the system architecture. Okay, that's pretty much about authoring. Now, talking about traceability, the traces are more specific than just trace relation, right? They are like satisfy is how solution architecture satisfies requirements. Then refine, and let me switch to Magic Grid based method based project, and then we have refine relations. So refine is how functional functions like use cases, structural elements like where the system exists, in which context, what's the context of system, what are MOEs, measurements of effectiveness, how they refine those requirements as stakeholder needs. Then we have derive relation, which pretty much derives from stakeholder needs to the system requirements. You see here, even implied derived relations we can show in matrix. Then we have satisfy relations, as we discussed. And we have ability to show those relations in different ways. We can show in diagram, as you saw, in the table, but also we can show in relation map. You see here we have derived and ownership relations, like own the composition, and then derive between stakeholder needs, system requirements, and preliminary design. And here is another satisfy matrix. So we have a structural relation map, actually the composition of system shown in relation map. Those relation maps are dynamic, so you can create once and then drag whatever you want. Select, for example, containment tree, and then just drag that, and this will recreate that piece of relation map. Okay, we covered traceability. Based on the traceability, we can do change impact analysis, coverage analysis, and we'll show some of that as part of the change. Now let's go back, and now we'll go to the validation and verification. So here we have this requirement, but there is also use cases, right, in the model. What system shall do, and what is the behavior of the system? As a result of that, you see this system behavior captured in the as a mission kind of profile of that system. Here we see that system should switch from turn off state in state diagram, based on this trigger to the initialization. Then it's if correctly initialized one path, if correctly then this path, if not correctly this path, go to flight, and then there's behavior side of the system. Doesn't matter that it executes, through the actual changing parameters, but the behavior is still defined, so we can execute that system model and see that it actually performs as required, like send signals through interfaces and so on. And with the help of the analysis, actually we can do the verification of requirements. And that's like two things: validation and verification. Validation is adoption of the system, and verification by the user, and how it will support user needs and stakeholders needs. And verification is it working as defined. So now we will simulate it. Here we see parameters based on this parametric diagram calculated. So fuel percentage, let's say 50%, it recalculates, you see, and this requirement, you see mission range on bad weather is immediately satisfied or not satisfied. If I will put 100%, here you see still not satisfied, right? And then I can run through the behavior side. Not even that I can run through the behavior side, I can even capture that behavior sequence diagram as a log file or the trace. So here we have the sequence diagram available. Then I switch to state machine and run that state machine. You see, I see immediately it captured, right? So I can go through that scenario and I see it captured, and I see at any moment what is the requirement status, right? It's always not satisfied. I can even track it in the time series chart. Right click here, shown time series chart. Let's do this. Come on. So pause, right click, showing time, right click, showing time series chart, and then oh, it didn't pause. Okay. And then they see like, okay, this requirement is not satisfied. If I will change something in the system behavior, for example, based on this system architecture here, I have ability to assign different airframe sizes from alternatives. As you can see here, airframe A, B, and C with different properties. So I could actually stop the execution, right? Assign different airframe and run it again. Maybe I will do it, but like right now I want to actually show that not only that I can capture the system behavior here in state machine in the sequence diagram. Actually, I will move this one here to choose between different airframe sizes and do the trade-off and see what's the best configuration. So simulation run. And I can choose the configuration directly here. So airframe system, remove values, add. I choose, for example, B configuration. Still requirement is not satisfied. And then remove values, add value C. Okay, still not satisfied. Remove values, add value A. Okay, now requirements shall be satisfied, right? But however, something is wrong here. So maybe the requirement text is wrong. So I will go here, tools, options, and project usages, no. Options, project, requirements, use pattern to recognize text. So now I'm switching on this recognition, and you see this is shall be more than 100. It actually recognizes it as equal. Shall be no less misarranged on bad weather more than 100 kilometers. Okay. Misarranged on bad weather more than 100 kilometers. And now I can actually execute this model and see how that affects different airframe sizes. So one I will remove, and add another one A, you see now it is satisfied, right, with this airframe size. Now I can actually choose this airframe size and save this configuration into the instances and see how those requirements are satisfied with alternative configurations. So here we see, for example, this is my configurations, and I just saved one, you know, so this was like airframe saved here, and I could and I can actually even delete those configurations here and even create new results of configuration, create new one, for example, here, choose whatever airframe I want, and actually here, for example, B, and recalculate all of them. Just run, evaluate, yes. See one by one they are evaluated on different airframe sizes, and then verification legend is shown, and then I can order, and I see that those three configurations actually satisfies requirements, other configuration don't. We can change also parameters here, like any parameters which I input into analysis. And also on top of that, I can actually take this whatever configuration, let's say this latest configuration, selecting containment tree, and I can go requirements table and say, show me based on this configuration what is the requirements verification status. So I see that it's actually based on this property, bound is more than 104. That's the limit. I have value which comes as a result of analysis of 129, and the margin of satisfied requirement is 25. Now next step, let's see. So now next step is configuration management. So when we work with requirements, likely we work in repository. So here we have Teamwork Cloud as repository, and we can commit the changes to repository. So let's do those changes. Let's commit changes to the server, and that's how like we say that okay, we are working on some specific and we can specific request. We can change that request from the history of the comments, and then requirement update, for example 111 based on ticket ID XYZ, and then we can also specify tags as a baselines, and you can commit the changes. Now once the changes are committed, you always will have them in the repository. There is no way to delete that historical commit, and all those changes are tracked actually at the single element level. So if I want to say how this changed, I can right click and say history for element, whole diagram, package as a scope, and whole project. So I can go here, right click, history, and that's because it is database. It extracts the changes and shows me what are the changes you see at which version, who did, and which what command changes for this specific element. They can compare, you see, between the last and recent one, and do quick diff. And that's how I see that, okay, completely text was changed, you know, between those versions, and from 120 we changed to 14, right? And I know who changed that, you know, and what was the command, what was the reason, right? And so that was quick diff. And also I can see that same information here, just at the different level, at project level. I can go to the collaborate project level, I can go to the history and then see who changed, and then I can select two versions and compare the whole project level. Also can do that at the scope level, for example, package, right click, and the content history, and see how the content where that element specifically is available, or like all the elements available, how they change. So double click on to see the changes. So for example, this was first, this is the last. I just double click and see how that, you see what was changed in the last commit. See requirements table change, and this requirement on the bad weather changed, and I can see like quick diff what's changed. You see that what's changed between version 4 and 6 if in that commit for this specific element. But that's what I see like for whole commit, for the whole content here in this whole package. Okay, now let's go to the next topic, is actually synchronization with external requirement management tools. So we support data as part of the data hub. You can see this data hub in resource plugin manager data hub. This is a built-in plugin in Catia Magic portfolio and a separate product in the Cameo portfolio. We support ability to synchronize requirements with external data sources between Doors, JAMA, which is coming in next release, and preview version is available now for JAMA, Doors next generation and traditional, and also traceable requirements management in 3D Experience platform. So for that, what we will demonstrate, we will log into 3D Experience platform here, to the platform part which have requirements. And we can expand them. And now let's go to the original location of those requirements in 3D Experience platform. Here we see those requirements. We can change those requirements. We can do see the workflow here. For example, we see the workflow for each separate requirement. And let's do the change. So let's change this arrange on bed Weber to the, let's say, for example, something like 80. And you see that we can do the change. The requirement is still work in progress. We still can synchronize, but actually if you want to do the revisions, you can also do it and then synchronize them based on the baselines. And here now to check the changes, we can right click on the scope which was synchronized. You see this S letter shows that it is synchronized, and right click on the scope, check changes recursively. And we see which requirements was changed. We see what was the property change. You see like 80 from 104. And then also we can select which direction the synchronization will happen. So from here to there, because we did that deliberately, synchronization established was bidirectional, which we can actually limit just to one way. Okay, now we are synchronizing, and you see the change happened. We see this requirement got updated, and then I can go to collaborate, to analyze, check suspect links. Suspect links show suspicious, and I will see impact of that change to the model element. So for example, here in this diagram, I see that, okay, based on that, this property is impacted. I don't know where is that, but I can see based on adornment, you see like it leads me to this specific element, and I can find where that specific instance of the model is, where that which satisfies this requirement or links to this requirement in other way, and that might be different role who needs to update this part of the model. If everything is okay, for example, in this case, I would run the analysis and see that maybe not that configuration is optimal anymore. So I just go to instance table and rerun all the analysis, reevaluate everything. And I see different flight distances. And based on that, I can sort them, and okay, now the change happened, and my new limit 180 is satisfying those requirements. Those configurations are, all of those configurations are now satisfying requirements. So I can choose the configuration with the smaller airframe size. I no longer need that large airframe size. So now we see this requirement updated, and we can rerun simulation. So we can go here and rerun simulation and see that this requirement is actually, for example, even delete those values and run again analysis, evaluate, and see that requirement is satisfied now with maybe less demanding, here you see this flight distance actually, with less demanding characteristics on the airframe of the system. So for example, this one is still satisfying, so we don't need a bigger airframe to satisfy based on the requirement change. Is collaboration and documentation. So you directly can export model to the Cameo collaborator, which is web-based publishing platform. It's part of the Teamwork Cloud. You can just publish like this and choose version, new version options. So for example, comments in project, enable editing, enable commenting, update previously published version, and you just click publish. Once you publish, you can actually go to this repository where this project exists. I can go actually to see resources, all the projects available, user rights, and so here it's in the web. I need to log in to see the data. I can refresh now to see the latest version in Cameo Collaborator because I just republished that. And now I can see the table with requirements. I see that all the model, can navigate through the model, you can click back, you see you can go to the requirements, go to the requirements diagram, requirements table, see the latest data, you see which we had, margins and everything. I can actually even edit this requirement table and values. I can publish that to PDF here directly. Export to PDF, can generate PDF of this model. I can export whole model to PDF. I can go and add comments. I can comment just text, or I can add model-based comments like this. And here we see this comment in the model. And what happens is new version is created. And when I want to see that, someone who wants to edit the model to check and update the model based on the comment, I can just click here and open this new. You see, I could open this project through URL in my. Now we will switch Cameo Collaborator comments in the Cameo in Catia Magic. So Windows Cameo Collaborator, and this allows us to access those comments and see even visual markings. So this allows us to actually fix the issues reported by the audience, which we are working on the model reviews. Here you see, I can actually reply, updated in version XYZ, and I can say, okay, no longer show me this marking, and this also. There's option just hide those markings in general, you know, if we don't want to see. So we can actually collaborate here, and we can see what was marked from the web. So that's how Cameo Collaborator works. It's not only review tool, it's not only visual demonstration tool, but actually also ability to collaborate. And also what we can see in Cameo Collaborator that we can actually export links, direct links to diagrams, and have the HTML code to embed them in some external sources like wikis, in Confluence, make it public, get link to the latest version, link to specific version, and copy that, and that allows us to see the live content in that wiki from Cameo Collaborator published diagrams. That's another amazing capability with the Cameo Collaborator. You can find much more in the wikis, and in the wikis here, which is community, which has the wikis which supports is supported by us and actively managed as Magic MBSE Cyber Systems community. Also on YouTube channels, MBSE Execution and Catia MBSE, you can just click on this magnifying glass or search for the content. And also there is documentation dedicated for requirements management. You see here web pages. So for example, here documentation, if I will requirements management, I will find that capability here, you see, in documentation. Then if I will YouTube, you see here, this is general. A lot of different content comes from research and development organization here, but also here you can find, for example, missile system, the same content, the same demo, and also other related demos, and also, for example, hearing aid, how requirements are related to whole digital thread, demonstration and sample wikis here, for example, for a whole digital thread wiki, post here for the Cameo data hub as integration framework. Here we see the model-based validation and verification of requirements. All of that is available in this community, MBSE Cyber Systems community, link you saw in slides, and then clicking here, by default you go to the post, right, and then you can review the post, but actually you can go here, click on wikis, and then see those wikis here, and then go to required content, like for example product usages, and see the content model-based validation and verification and so on. A lot of keys that in the future we'll share more on this topic, because we touched how to work with SysML, but that is actually system architecture which expands to the requirements repository. Again, we discussed that, but then there is like requirements variance management, code generation, design model export for the continuation and design disciplines, Power BI for the repository and for the experience platform, traceability, requirements analysis, and check with the stimulus, with the automatic generated test cases as a stimulus, right? Then requirements optimization, system architecture optimization, and trade studies with multidisciplinary models based on process composer capability, and then multidisciplinary simulation for electrical fluidic with the DIMOL, and all that integrates to Catia Magic, and requirements a big part of that. So thank you. Let us know if you need some help on requirement management in SysML with 3D Experience Platform or Catia Magic.